Now let's study liver. The liver is covered by peritoneal mesothelium. The inferior surface of the liver has a deep concave recess with a central hilum called the portal peptis, where blood vessels, lymphatic vessels, and nerve fibers enter the liver. The liver is the largest exocrine gland in the body. It secretes large amounts of bile. The liver also performs endocrine functions. It synthesizes and secretes blood proteins such as serum, albumin, and transferrin. It regulates blood sugar level by storing massive amounts of glycogen. The liver is the primary site for the detoxification and elimination of body waste and poisons. So, the liver is the chemical plant of our body. The connective tissue septa enter the parenchyma of the liver at the hilum to divide the liver into lobules, hepatic lobule. The red square shows, which is the structural and functional unit of the liver. Portal vein is the functional blood vessel of the liver, which conveys blood from the pancreas and spleen, and blood-containing nutrients absorbed in the intestines. Hepatic artery is the nutrient vessel and supplies an adequate amount of oxygen to hepatocytes. The branches of the portal vein, hepatic artery, hepatic duct are located in the connective tissue among the hepatic lobules called portal space. The yellow square shows. If you want to understand the structures and functions of the liver, you must understand the structures and functions of the hepatic lobule and portal space and the relationship between them. So, above the liver, hepatic lobule and portal space are the emphases. In the liver of a human, the lobules are in close contact along most of their length, making it difficult to establish the exact limits between different lobules. But in certain animals, such as pigs, the lobules are separated from each other by a layer of connective tissue. Firstly, we will study hepatic lobule. There is a central vein at the center of the hepatic lobule. Hepatic plate, hepatic sinusoid, perisinusoidal space, and bile canal nucleus are distributed radially from the central vein to the periphery of the lobule. Hepatic plate is formed by hepatocytes, which are arrayed like the bricks of a wall. These hepatic plates are directed from the periphery of the lobule to its center and anastomose freely. In the section seen by HE, the hepatocyte appears polyhedral with 6 or more surfaces. The cytoplasm is eosinophilic with some basophilic clumps, 1 or more nuclei in the cytoplasm. The number of polyploid hepatocytes is large, and more than 6% of the adult hepatocytes are tetraploid, which is related to the long-term active state and the strong regeneration ability. The hepatocyte is rich in nearly all kinds of organelles, such as RER, SER, GC, mitochondria, lysosomes, and so on. It is also the cell with both endocrine and exocrine functions. This is the liver seen by PAS. We can see numerous glycogen granules in the cytoplasm, seen in purple red. The hepatocyte contains three functional surfaces: sinusoidal surface, canalicular surface, and hepatocyte junction surface. Hepatic sinusoid. Hepatic sinusoid is located between adjacent hepatic plates. Sinusoid capillaries are irregularly dilated vessels composed solely of a discontinuous layer of fenestrated endothelial cells, in which materials exchange is realized between hepatocytes and plasm. Perisinusoidal space or space of Deasy. Perisinusoidal space is an interstitial space between endothelial cells of sinusoids and liver cells. It is the site of exchange of materials between blood and liver cells. In the perisinusoidal space, we also can see some fat storage cells, also called Etos cells. The cytoplasm of Etos cells contains vitamin A-rich lipid droplets. More than 80% of vitamin A absorbed from food is stored in the Etos cells. Bile canaliculus is a small canal formed by opposed grooves in the surface of adjacent hepatocytes. Bile canaliculi are closely-ended near the central vein and also radiate from the central vein to the periphery. The bile flows from the center to the periphery. At the periphery, bile enters the interlobular bile duct by Henry's canal. Portal space. Portal space is present at the corners of the lobules, containing interlobular artery. A branch of hepatic artery carries oxygenated blood up to liver, providing nourishment to hepatocytes. Interlobular vein. A branch of hepatic portal vein carries metabolic substances and nutrients from digestive tract to hepatocytes. Interlobular bile duct carries bile to left and right hepatic ducts. This is the pattern diagram of the portal space. Interlobular vein is the largest in the cavity. Interlobular artery contains several layers of smooth muscles and a small cavity. Interlobular bile duct is lined with a simple cuboidal epithelium. Now, let's distinguish these three types of vessels. The star shows interlobular vein. The cavity is the largest. The arrow shows interlobular artery. The wall is eosinophilic. The triangle shows interlobular bile duct. The wall is basophilic. In the hepatic lobule, the blood flow progresses in a direction opposite to that of the bile, from the periphery to the center. This animation shows the flow of bile and blood. The green is the bile flow. The red is the blood flow. Their directions are just opposite. Now, let's look at the clinical case. First question. The liver belongs to the digestive system. Second question. Long-term heavy drinking will affect the normal function of the liver and then cause hepatitis. Long-term heavy drinking can lead to toxic liver damage, early fatty liver, then alcoholic hepatitis, liver fibrosis, and finally cirrhosis. So, patients with alcoholic hepatitis symptoms should quit smoking and alcohol, eat light and easy to digest food. Okay, that's all. Thank you.